Hello everyone, welcome back to Studying with Zahra. Today I'm going to be doing Unit 7, Radioactivity and Particles, and this is a Decalage GCSE. I'm going to start with atoms and radioactivity and the basic sort of atomic structure. I'm going to go over it very briefly because I feel like it's pretty basic. Everyone knows it. It's in chemistry as well. So the electron is a very small particle. It has very little mass. It has a negative charge. The nucleus is very small compared to the size of the atom itself. And the electron orbits the nucleus of the atom. So I'm just going to draw a really simple atom here. I have my protons, my neutrons. That forms my nucleus. And then around it, I have a shell. And there's no guarantee on how perfect these drawings will be. Okay. So this is my electron. Proton. Neutron, which has no charge. And then this is your shell or your orbit. And then this whole entire thing is your nucleus. And try not to get this confused with the nucleus in biology. So, the diameter of the nucleus is about 10,000 times smaller than the diameter of the atom. The nucleus is made up of protons and neutrons. And protons and neutrons have a relatively similar mass. And they're nearly 2,000 times heavier than electrons. So electrons, as you can tell, are really, really tiny. And protons carry a positive charge. Neutrons, as the name suggests, are electrically neutral or uncharged. And the amount of charge on a proton is equal to that on an electron, but it's opposite in sign. So a proton is a positive charge and an electron is a negative charge. I'm going to draw a little table here. Electron, proton, neutron, 1, 2,000, 2,000. This is the relative mass that we're drawing here. Okay, and then relative charge, -1, +1, and 0. So that is our subatomic particle structure. So the atom is electrically neutral because there's equal numbers of protons and neutrons. The symbol we use for the atomic number of an atom is Z, and the symbol that we use for the mass number is A. So for example, I don't know what atom to choose. Should I do, I feel like hydrogen. We could do helium, for example. So that would be 4 here and 2 here. And this number right here, if I was to give a general symbol overview, it would be an A. This number would be a Z, and then the atom itself, the element itself, would be an X. So that would be the symbol representation of any atom, the atomic notation of any atom. Atomic notation. And just remember A, X, Z, and then just split it up in this order. So, the mass of a proton is approximately 1.7 times 10 to the power -27 kilograms, and the mass number of an element, again, is given by the symbol A. Each particular type of atom will have its own atomic number, and it identifies the element, and a mass number depends on the total number of nucleons or the total number of particles in the nucleus. So the mass number is the sum of the protons and the neutrons, and the atomic number is the proton number or the electron number if it's a stable atom. And the proton number always stays the same no matter what. The electron number is what occasionally varies in an ion. So yeah, next we're going to be talking about isotopes now that we're done with the whole atom shebang. Actually, I'm going to use a different color for this just to make it a little bit easier. Go for that color. Okay. It's a little dark. Perfect. Isotopes. So, isotopes of an element have different physical properties from other isotopes of the same element. Now, the explanation for an isotope is the number of protons in an atom are what identify the element, and the chemical behavior of an atom depends on the number of electrons it has, as we previously saw. And this always balances the number of protons in the nucleus. However, the number of neutrons in the nucleus can vary slightly. Atoms of an element with different numbers of neutrons are called isotopes of the element. The numbers of neutrons in a nucleus affect the mass of an atom. Different isotopes of an element will have the same atomic number, Z, but different mass numbers, A. So for example, we're going to take a look at hydrogen. And this is going to be, I'm going to use different colors here for each subatomic particle. The blue is going to be my electron. The purple is going to be my nucleus. So this is hydrogen 1. And this is going to be the structure of hydrogen 1. We have 1 proton. Over here we have 1 proton and 1 neutron. Over here we have 2 neutrons, 1 proton. By the way, they're actually a lot bigger than this. In the diagram that I drew, the protons and neutrons look smaller than the electron, but they're actually bigger. This is hydrogen 2, which is going to be 2H1, and then this is hydrogen 3, which is going to be 3H1. So the only thing that's different over here is over here we have 1 proton and 0 neutrons in this case. 0 neutrons, 1 neutron, and over here we have 2 neutrons. That is what makes an isotope different from another isotope. So they have different physical properties from other isotopes of the same element. One obvious difference is going to be mass. Another difference is stability. The protons are held in the nucleus by a nuclear force. And this force is very strong and it acts over a very small distance. If it is strong enough to hold the nucleus over together against the electric force, repelling the protons away from each other. Because we know that like charges repel each other, and these forces that are in the nucleus, they're so strong that they can keep the protons that are essentially trying to move away from each other, because they're meant to repel each other, they're meant to move away from each other. But these forces are so strong that they can overcome that repulsion and keep the protons together and keep them in place. So the presence of neutrons in the nucleus affects the balance between these forces, and too many or too few neutrons will make the nucleus unstable. An unstable nucleus will eventually decay. That is our key point. So if we have too many / too few neutrons, will lead to decay. And that is going to create this whole entire, that's going to be the base of the whole entire topic of radioactivity. So when the nucleus of the atom decays, it will give out energy. And we're going to go over what exactly decaying means in the next video. But it gives out energy. And it may also give out alpha or beta particles. Now again, this might seem a little bit confusing right now, but we're going to go over this in the next video. But for now, all you really need to know is isotopes, the structure of an atom, and all that stuff. And if you really understand this, then hopefully the next few topics of radioactivity shouldn't be an issue. Anyways, thank you guys for watching. Please like this video and subscribe, and let me know if there's any other topics that you guys would like for me to do from any subject: physics, chem, bio, math, English, environmental management, sociology, whatever it is. Just let me know.